Welcome to Ask and Learn.
All right. So this problem, we have this is a chinook. So suppose this is the mountain, and this is the Denver city, and the wind firstly come from this side and climb on the mountain, and it descend the slope. So the problem says that as the wind go from the top to the bottom, the temperature T of the wind will increase. So why the temperature of the chinook rises as it descends slope? So firstly, we know that the speed of the wind is actually very fast, and if it is fast, uh, suppose this is the sun. If it is fast, then the time that the wind accepts the sunshine is very short. So in this case, we can suppose that the heat that the wind accepts is very small. It is almost negligible. So Q is almost zero. And in this case, we can see that this process is very close to an adiabatic process. So for an adiabatic process, we know that P times V gamma is constant, and combined with PV equal to nRT, we will obtain the relation T gamma over P gamma minus 1 is a constant. And typically, we know that the pressure on the top of the mountain is very small, and the pressure on the bottom of the mountain is actually larger. So in that case, because we know that this formula has to be a constant, if P is larger, then T has to be larger. So the pressure here is small, then the T here is small. The pressure here is large, then T here is large. So this is small. Small. This is large. So that's why as the wind descends the slope, the temperature rises. And for part B, so we know the pressure on the top, and we also know the temperature, and also we know that before the wind arrives, we know the temperature and the pressure. So we want to calculate how many Celsius degrees with temperature rises as the wind arrives. So to figure this out, we still need to use this formula. So T gamma, T gamma, let's say top of the mountain over P top gamma minus 1 equal to the temperature at the Denver city, T Denver gamma over P Denver gamma minus 1. Okay. So the temperature on the top of the mountain is given to be minus 15 Celsius degrees, and the pressure is here. And the temperature at the Denver city after the wind arrives is unknown. Actually, this 2 Celsius degrees is the temperature before the wind arrives. But we know the pressure for the city. So basically, we can calculate this TD by using the other threes. The other threes, they're all the known variables. So TD, you still need to transfer the Celsius degrees into Kelvin degrees. Okay, so that's a relation that also minus 273 degrees. So TD is calculated to be, so just move this to the left hand side, and we obtain TD is T top times P D over pt with power gamma minus 1 over gamma. And remember that for air, because air is mostly consists of nitrogens and oxygens, and both of these gases, they are bi-atomic gases, so gamma equal to 1.4 for the air. And you just plug in this number, and this pressure into this expression, and you will figure out that TD is 13.9 Celsius degrees. I remember that this temperature is the final temperature after the wind arrives, and we need to figure out how many Celsius degrees rises. So basically, delta T equal to this 13.9 minus 2. Here is the 2, okay? So final result is 19.9, 11.9 Celsius degrees. Yeah, that's it.